So this is the introduction video to assembling the VT132. There's always some things to do ahead of time before you actually break out the soldering pencil and go to work. And the first thing is to examine the printed circuit board and become familiar with it. We'll go over the board here together. So this is a plot of what should be the final version of the board. Dave may update this at some point. It's the latest I was provided. Let's take a look and see what all we've got here. So we've obviously got two switches up here, a switch to program and a switch to reset. We've got some discrete components down here. There's a single transistor, there's an electrolytic cap that's marked C3 100 microfarad. There's a 100 nanofarad and a 1 microfarad disc cap that go here and here. So you want to make sure you get the right cap in the right position. And there's one resistor that gets mounted vertically rather than horizontally on the board, and that's R5 here. And that may not be obvious. So R5 will vertically go down through the board, and then the wire on the top of the resistor will bend down the side down here. So this resistor in this case stands up off the board, but there's plenty of other components here around it that's just not an issue. The rest of the resistors all lay in flush. There's a piezo buzzer to generate key clicks and end of lines, those kind of things. The little piezo unit itself has a plus symbol molded into the black plastic case. That, of course, lines up over here to this plus symbol. We have a PS2 connector over here for a PS2 keyboard. We've got a VGA connector here that you use to connect the VGA. Some pin headers, one for the modem and one for the FTDI. I don't know that a typical user is going to need to install these, honestly. Going into an RC 2014, they're probably not useful, although if you want to install them, feel free. There's a couple more pin headers down here. This one, JP5, has got to do with, if you're using this pin header, taking the 5 volts from the pin header and powering the board from it. You put the connector on to power the board from here. You put the connector on JP6 over here to power the board from here. Normally, plugged into the RC 2014 bus, you're going to get power off the bus, and these jumpers would be removed. You really don't want multiple systems, providing 5 volts onto the bus. A couple more electrolytic capacitors down here, 10 microfarad and 22. The dark black section over here is the negative of the capacitor, the same up here. They're polarized parts. Pay attention to the polarization on the markings on the cap. One transistor also has an orientation that goes in. The plastic molding of the actual transistor will have this flat face on it, so obviously it lines up here. We've got a bunch of resistors. Some of these markings are easy to recognize. 10K resistor for R5, 120 ohm for R1, 2K for R3, 10K here for R13, 4.7K for R12. These over here may look a little odd to you. This is a set of precision resistors that's used to do the color generation for the VGA. I'll just put it that way. And this is a precision 405 ohm and a precision 806 ohm. So where most of us are used to seeing values like 2K or 120 and just going, yeah, resistor, these may throw you a bit. They really are resistors. They're just high precision resistors. Another pin header down here that needs to be installed, or jumper links installed. I installed a pin header and put the little jumpers on the pin header. These are what connect the VT132 to the RC 2014 bus. These will not normally need to be jumpered for normal operation with the RC 2014. Have I missed anything here? Well, we're down to the surface mount components. We've of course got the ESP32 that, for what I've got, solders onto the set of pins around here, and we'll look at a little more detail how to solder that. I will give you a hint that flux is very much your friend. And we've got a little 3.3 volt regulator that takes that 5 volts coming onto the board and regulates it to 3.3. And again, it's only got 4 solder connections. There's these 3 pads and this kind of heatsink pad out here. So definitely take a look at your board, become familiar with it, kind of know where things go ahead of time. Kind of think about your order of assembly. You're definitely going to want to do the surface mount components first. Trying to solder these surface mount pins over here with these components stuffed would be very difficult. If you're like me, you don't have a way of using a reflow oven to solder these surface mount components, so you'll be using a soldering pencil. Like I say, we'll cover that in a future video about my approach to this. There's a few approaches. Uh, Definitely the surface mount going first. And then I tend to work from the lowest profile to the highest profile components. It would be surface mount. It would be the horizontally mounted resistors. Probably these two jacks, or maybe even all four, or these pin headers, maybe even all four. Potentially from there, it might be the transistor, the capacitors, this vertically mounted resistor, the disc caps, eventually ending on the switches, the PS2 and the VGA connector, because those are going to be the highest profile most likely. So with all that said, let's take a quick peek at the back side of the board. It's just what you'd expect. You know, the mirrors of what we've just seen, all the places you're going to solder. For the PS2 connector, definitely solder these three strain relief holes here. Those hold the actual PS2 connector tight to the PC board, and that way when you're plugging in and out the cable, you're not stressing the solder joints here that actually contain the power and data symbols or signals. I recommend doing the same thing for the VGA connector, where you solder these larger holes here as well. There should be a little prong that pokes through from the PS2 or the VGA connector through the holes here. If you solder those, it'll help with strain relief, and you're not putting pressure really on the solder joints here. I'll mention this, and it'll get mentioned again. When you solder up the VGA connector, make sure all of the pins are through holes before you actually apply solder. It can be easy to bend one or more pins over and not get it through the board, and it really sucks to get halfway through soldering and go, where's that pin? Removing these isn't difficult. If you've got the right tools, it's something you don't want to have to do. Check that all the pins have come through. Same thing here for the PS2 connector. Check that all 6 of these pins have come through the holes before you solder. Same thing here on the switches. There's the 2 pins for each switch where the signals happen, but there's also a stress relief here. The metal body of the switch actually will come through these holes here. Solder these up. It'll provide stress relief, so you're not stressing these solder joints. The rest of this is pretty standard through-hole stuff. You've got resistors. There's some resistors over here. You know, pretty standard stuff, but definitely look at your board, think about your approach, and really then move from there. So the second piece to assembling this is to look at the BOM, or the bill of materials. And I've got a copy of it open here. So I went out to the website that Davis provided, the high nibble, and I copied out the actual pages here that have the component descriptions, the BOM, because I like to print that out and work from it. There's obviously 2 surface mount components, the ESP32 and the voltage regulator. Your ESP32 may be packaged different or repackaged back into this. I'm not sure how Dave's going to approach it. He's planning to sell these pre-programmed, so you won't have to do that step yourself. And like I said, I don't know how he'll handle the final packaging of that. Make sure you have both components, and look over here in the description and read the notes. I missed a note in the first one of these I assembled and made a mistake. So definitely pay some attention. There might be late minute errata kind of stuff added here that you should know ahead of time. And whether you're looking at this on the website or a printout, you know, either way, take a look. We get down to the through-hole components. Dave is very kindly writing the values on them here, but make sure you have the right resistors. So work through this, look at the notes. There's notes here giving you the color bands in case these get detached. More resistors, the 806 ohm precision resistors, the 405 precision resistors, the single 4.7K, a couple of 10K. And then there's 2 caps here. There's this 100 nanofarad, and it will be marked on the package 104 typically. So 104 is indication of 100 nanofarads or 0.1 microfarad. Like I say, you should see 104 printed on the package to know which one that is. There's a second disc cap. It's a 0.01 microfarad, labeled 105. Again, it should be labeled on the package. The electrolytics will have markings on the package for the polarity. Usually the negative lead is indicated. and it'll have the capacitance rating, 100 microfarad, 22, and 10. And David just made note here, pay attention, polarity matters with these. Get the negative marking typically on the package to the part of the silkscreen that has the negative on it. And just again to look at the silkscreen, that negative is indicated by the black over here on this side, so the negative lead would go here. And typically the positive lead goes through the pad that is square. You'll notice the same thing here on the buzzer. The square pad gets the plus lead. Pay attention, these are polarized. Let's jump back into what I've captured here. There's that single transistor. As I said, the plastic package has that same kind of half moon shaped outline. Make sure you get it in correctly. The tactile switches, the 2 pins on the front that are the data signals, and then the kind of bent pins out here are the stress or strain relief or stress relief, whatever you want to call it. I recommend soldering those in once the switches are in. By the way, there's 2 of these switches. There's the little buzzer, the piezo buzzer. You probably can't see it here, but on this side over here, there's a little black plus. If yours doesn't have the black plus, look on the back of the buzzer. Polarity will be indicated in some way on the package. This is where I made my mistake. I missed totally his note here that the plus VE, it must be inserted the correct way around, plus VE to the square pad, plus VE being the pin here marked V. I missed this. I made a guess, installed it backwards. Had I actually taken the time to read these as I'm recommending you do, I would have caught that. There's a couple of the right angle 2-pin headers. There's a couple of right angle 6-pin headers. There's the straight through 8-pin headers. There is the large double row right angle connector that connects you to the RC 2014 bus. And finally the VGA, well not finally, the VGA connector, and I think finally is the PS2 connector. And of course the printed circuit board. Compare your parts against the BOM, look for any errata. If a resistor value was to be changed for some reason, that would most likely be called out in the errata. But make sure you've got the right parts. You don't want to have to pull a part out because you put the wrong resistor someplace, etc. It's just easier to get it right. That little bit of investment in time up front can make a big difference about getting a kit together correctly and having it work on first power up. Again, I highly recommend compare the BOM to your parts, plan the assembly, get to know the printed circuit board, and then dive in and begin to do the work. A little bit of planning up front can pay huge dividends on the other side of the assembly. I think with all that said, I'm going to wrap this up here, and I'll see you in the next video.